Okay, welcome to this video where I'm hoping to advise you on which AQA Physics A-Level option topic you should choose. These are my personal opinions, but they're aimed at the physics students currently studying at Godalming College, and they're halfway through the second year of their course, and they're about to make the decision which option topic to choose. This is a little bit of advice which answers a lot of the questions I get asked every year. I'm really hoping that you already know that there are 5 options: engineering, turning points, electronics, astro and medical. So I'm going to whiz through them to give you an idea which one is probably best for you. Ultimately, the latest we can really get the exam entries in is just before the Christmas holidays. So I'm going to, if you're at Godalming College, I'm going to ask you to sign up online via Godalming Online. Then ultimately, straight after I make that, the exams office will put the list into their system and it will come back to me saying this is what you've chosen, just for double checking, and I will double check with everybody that what I've put in is what you think you've said, and that really will be your absolute last chance to make a change. If you do make a change afterwards, there is an exam board fee for the administration. Crucially, it's not like an option that you sometimes see in other papers where you can just choose one of the questions from 5. You will be doing a different paper. So if you study for astrophysics and you've actually told us you want to do medical, you will be given the medical physics paper and there'll be no opportunity to change. Obviously we will sort it out, but it is a right faff to make a change once exam entries have been made. And as I say, as soon as it's gone off to the exam board charges a fee, so we'll obviously have to pass that on to you. That fee does go up as we get close to the exam. I don't know the exact scales, you can look it up on the AQA website, but it ends up being quite large if you change your mind later on. Crucially, if you do change your mind, it is not the physics department that can make that change. You will have to go straight to the exams office, who will then liaise with me to make sure that that makes sense. Please, now is a great time for you to do this. You haven't got mocks, you have handed in your UCAS, there's probably no big coursework deadlines, so this is the perfect time for you to spend a few minutes having a little look through this material and making sure you choose carefully the option topic. So what am I going to do? I'm going to whiz through the content, really brief overview, because your job is to look at the content. I'm going to perhaps discuss some of the skills required, talk about the sort of students that have been successful in the past, and then just mention any extrinsic reasons. Things that might influence you that are not to do with you or the department or what's being learnt, where you might progress to, things like that. Right, let's start with engineering physics. Sometimes we say this is really for the further mathematicians. I think we can go a little bit wider than that, but certainly if we're looking at the student profile, you've definitely got strong maths and you enjoy problem solving. There's not that much content. Rotational motion, which is effectively SUVAT but going around in circles. Obviously looking at momentum and energy as well, but basically flywheels, yo-yos, anything that goes around in a circle that involves complex changes, you will look at. And then the second half of the course looks at thermodynamics, conservation of energy, engine theory in general, and then you'll look at specifically at combustion engines, diesel, petrol, and you'll also look at heat pumps, reversible heat pumps, so effectively air conditioners and fridges. So if you enjoyed the thermal physics topic and you enjoyed gases and you enjoyed mechanics in the first year, this is probably for you. Quite a few derivations, lots of tricky maths problems that you have to work it out, plenty of graphs to interpret, few things to learn but not as much content, if you think you're doing engineering at university or maybe as an apprenticeship, then this is an obvious one for you to look at. But make sure when you look at the content, you look at the problems, and you look at a couple of past papers, you are confident that you are going to be able to get the grade you need to through this. This is not, it's not right to say one's harder than the other, but certainly this one edges towards trickier problems with less content. Okay, turning points. This is one of 3 topics I think is a good mix of content and problem solving. This one probably edges towards the more content and understanding. There is a bit of maths in here, but it's not nowhere near as much as the engineering. 3 areas that we look at: the origin of the fundamentals of charge, so that's electrons effectively, obviously protons as well, but we look at thermic emission of electrons, and we look at the Aldrich experiment, which was the ultimate experiment that found out that the smallest unit of charge, obviously 1.6 times by 10 to the minus 19 coulombs. Then you look at wave-particle duality, light as photons, and also the de Broglie wavelength. This is pretty much a complete recap of the quantum physics, with a few extra bits thrown in, and those extra bits really help you with your understanding of quantum. It's nice, I like this topic. Then the final section is special relativity. General concept about what is relativistic thought, what do we mean by frames of reference, and then crucially it looks at Einstein's theory of special relativity, the mathematical derivation of that, which actually is much simpler than you think at this level, and what's the experimental evidence. There's quite a lot of history in all of this, so if you want to see what the origin of the thoughts that we have around the key concepts in physics, this is an excellent topic for you. So lots of content, bit of maths. If you enjoy sort of reading about how theories came about, maybe the experiments that proved them, and you think you can discuss those things and talk about the key features, this is for you. You might be looking to a physics degree, you might be interested in popular science more generally, you might be taking a complete tangent, and it is a nice history unit that you can get lots of marks from, but you perhaps won't use in the future. Turning points historically is the most popular topic that we run, but we don't push one topic over the other. Astro used to be the most popular. Before turning points got added in, Astro used to be the most popular. Astrophysics, this is a lovely topic, because there is a lot of astronomy and astrophysics resources around, and who doesn't want to see Brian Cox's smiling face expounding the wonders of the universe? This topic does have a bit of content, a bit tighter than turning points though. 3 main areas: how we observe the universe, what we observe when we observe it, and what conclusions can we draw. Telescopes, the process of observing stars, and things like the stellar life cycle, and different astronomical objects, so black holes and pulsars, and how do we know how far away something is. So basically the process of measurement, and cosmology, expanding universe, just touching into the dark matter stuff. So there's some really interesting stuff in there. There is a bit of maths in this, so definitely we're trading off some content. There's also a lot of linking things in together. So there's less of these really nice little discrete questions that say this question's about such and such. You have got to be able to make links across the topics. Lots of new concepts. Obviously, if you quite fancy learning about astronomy and astrophysics, this is the absolute perfect topic for you. You don't need to be a telescope nut to do this, but obviously if you are, it might make more sense. Again, this is a popular one for people going on to do physics degree, or it's just a nice popular science choice. Medical, lots of content here. This is probably the most content heavy. There is a smidge of maths still in it actually, but it's generally speaking lots and lots and lots and lots and lots of learning. Fortunately, the underlying concepts do reoccur throughout, so it's not as bad as it looks. The basic gist is what's the physics of the biological systems in the body? Eyes, ears and nerves. Then we look at a couple of, almost 3 different imaging systems. Non-ionising, which we split down to the use of optical fibres through endoscopy, ultrasound and magnetic resonance imaging. This is probably my favourite topic, if I'm going to be honest, because the physics behind these is really fascinating. And the application of this physics, which was started out as blue sky physics, and the difference it has actually made to people's lives, cannot be undersold. Then more traditional imaging techniques like X-rays and CT scans. And then we separate out another ionising techniques, particularly the use of radionuclides. So that might be the use of a gamma camera or positron emission tomography. And also the use of radionuclides in use of therapy. So radiotherapy usually for the treatment of cancerous tumours. If you're a biologist, there's an overlap. Possibly if you're a PE student as well, actually, there's a bit of an overlap. Not a huge amount, but a smidge. If you're thinking of doing nursing or medicine or biomedical sciences or pharmaceuticals, something like that, really you ought to do this. But there is a lot of content to learn. You've got to be up for, doing some flashcards, learning a load of stuff, doing mind maps, really learning how you can pull this stuff together. And finally, electronics. If you've got no background in electronics at all and you don't do computer science, you've got a lot to do, because there is very little overlap between this and the core course. Even with the computer science course, there's a little tiny bit of overlap. You're going to be taking on some tricky concepts, and there is some serious practical understanding in. There's no practical element in the exam, obviously, but there's definitely, if you haven't done some of this stuff practically, if you choose this, we will give you a box with a breadboard and you'll have to practically experience quite a lot of this. This is probably the most time-consuming option topic. There is a little bit of tricky maths in there. There's also a lot of detailed content. But if you already enjoy electronics and you're a bit of a hobbyist and this is stuff that you kind of understand, if you found the electricity topic in the first year really easy, and crucially, you're probably going on to do electronic engineering at university or maybe at an apprenticeship, then that's an obvious reason why you would do this. My only slight warning to any student that does this is you are up against candidates that are doing the electronics A level, where there is a massive overlap. So if you're up against a candidate who's basically doing this as their full A level as well, then obviously they are going to be able to produce a higher level of understanding with less work. So in terms of how the grade boundaries fall, I'm not saying it is trickier, but it's a competitive system. You do need to sort of be aware that this is possibly a trickier topic for a complete novice to walk into. So, here's a summary. Engineering. If you're a keen mathematician, don't like content, really good at problem solving, particularly if you're good at spotting which route to take. You don't mind the odd derivation. You don't mind the fact there isn't any overlap with the core, but the strong links that will improve your skills. Engineering is your one. Turning points and astrophysics, these are a good mixed concept. Astrophysics got a little bit more maths than turning points. Turning points got a little bit more historical context. Both have got some overlap. The biggest overlap is turning points, but those are two sort of mainstream choices. Medical, still a little bit of overlap actually, and with physics, and some overlap with biology. This has got the most content. And then electronics, a little bit of overlap with computer science, a little bit of building on with skills in terms of the core, but I'm hoping that you're going into this with some external understanding of electronics, because it will be tricky to cover it in the time. Right then, I was trying to do this in 15 minutes and I've almost made it. I hope that you have found that overview useful. What to do now? You really, if you're a Godalming College student, you really need to go onto Godalming Online, and you need to look at this site, the physics option topic. You can see that we've subscribed to various ebooks. We've got lots of resources. We've got various links, past papers, any videos that we've got currently on our media server, and you see there's an absolute ton of stuff on here. Okay, past paper questions, blah blah blah. The other place you can go is the textbooks in the classroom. We have got specific textbooks for all the option topics, and also a couple of the mainstream textbooks have got some option topics in them as well. I really like Anton on education. He's a great guy. He's put a huge amount of time and effort in. If you have a little look at his site, this is, I'll just bring the web down, antoneducation.co.uk. I'm not sponsored by him. Then you will see that he's got specific content on each of the option topics. He's got specific content on the entire spec, but if you were to click on it, we'll just choose Astro, you can see he's got a lovely little overview, and then he's got a massive amount on every single thing. He's got a load of content, and I've got this scrunched, but I'm trying to show you. He's also got some self-test little questions, little hot potato questions, and he's even got a bit of a topic test for each one. This is well worth a look. Then, obviously, discuss it with friends, family, decide what to do, and crucially, look out for the email and forum posts that came with the link for this video. The other link on it is to an online survey where you will choose which option topic you wish to do, and that has got to be done by the 13th, Friday the 13th of December. So that's the day after the election. That's if you're in the 2019-2020 course. If you're in a future year, it will be basically the penultimate Friday before we break up for Christmas. Hope you found that useful. Obviously, feel free to ask any of the teachers if you have any questions.